Networking, that's something developers should care about, or maybe not. That's the theme of this week's episode. Good morning, good afternoon. Thank you for downloading the AWS Developers Podcast. Spotify, Deezer, YouTube, Apple Podcast, all good podcast application. Last week, we start a fascinating discussion or dive deep into networking about why you as a developer, you should care about networking. And this week, maybe you will realize that actually you don't. And to explain that, I have the pleasure to welcome again Alex to continue the discussion that we interrupted last week. Alex Widish, your principal networking specialist, solution architect. Can you summarize in 30 seconds what we talked about last week? And if you're interested, you can go back in the history of your podcast app and download the full episode.
Yes, of course. Thank you, Sebastian, for having me yet again. Here, coming back on the podcast. Really excited to be here and to talk about this thing that is networking. And last week we talked about why you kind of should care about networking on AWS and why it's important and why it is the foundation that allows you to scale and grow your applications. This week, I think the most important thing we're gonna leave this podcast with is how can you not worry that much about networking on AWS? Not that you shouldn't care about it, you should, because it's still the foundation, it's still the piping, and it should still be there. But how can you care a bit less and make it easier to do and make it easy to place that foundation that allows your apps to scale, grow, expand, make sure that they meet all your business requirements. So yeah, that's in a nutshell, I think.
So on one side, ensure that we have all the foundation ready and solid and follow the best practices in terms both of networking but also security, because this is linked.
Exactly.
But without having the need to hire a networking team. I mean, we as developer, maybe we have enough tools or services provided by AWS to lay down the foundation for us more or less automatically, or you're going to explain that. But that's typically what AWS does. We identify and we remove the undifferentiated heavy lifting, like Werner Vogels like to say. We did that with virtual machines and putting server in the racks like 20 years ago, and we did it again with networking with that service that we introduced 2 or 3 years ago. It's called Lattice. So what is Lattice?
Yeah, VPC Lattice. I want to, though, come back a bit to the undifferentiated heavy lifting, and I think there is a really good analogy that people can have in their minds when they think about VPC Lattice. With the tools that we've talked about last week, with VPC peering and Transit Gateway and Cloud WAN and all these connectivity options that you have available on AWS to connect your services and VPCs, you kind of have the tools available to you based on the things that you are maybe more or less accustomed to from traditional data centers, right? It's layer 3 connectivity at the network level, right? IPs talking to IPs. We've talked about the mail delivery service last time. So that's kind of what these tools provide you, a different scale, right? VPC peering is less scalable, allows you to connect a small number of VPCs together. Transit Gateway is a regional construct, thousands of VPCs in a region connected to each other in a hub and spoke model. And Cloud WAN allows you to go global, right? Super easily connect VPCs around many AWS regions at scale. So layer 3 connectivity, standard things that, or the layer of connectivity that everyone coming from traditional data centers is accustomed to. However, coming to the cloud, a lot of that lift and shift and burden of sort of maintaining traditional concepts is lifted, right? It's simplified. So here is where Amazon VPC Lattice comes in into play. And you can think of it as, well, kind of don't need to know all the layer three stuff, right? I'm in the cloud. I don't want to know about the data center things. I don't want to know about routing protocols, and I don't want to know about BGP, which
Oh
is,
no,
yes, right.
except to pass the
Uh,
certification, but after that,
exactly. So I want things to work. I want things to be easy. I want my apps to just be able to talk to each other. I don't want to care about IP overlap. I don't want to care about all these networking constructs that I need to kind of deal with.
last week we talked about endpoint. As a developer, I have the endpoint of my database. I just want to talk to that database or to my web services, my REST API for something.
Exactly, exactly. So thinking in terms of endpoints is how developers in general these days, I think, are most accustomed to defining their intent for connectivity, right? It's like, this is my app, this is my endpoint, and I need to consume that other endpoint, and that client needs to access my endpoint. So those are the words in natural
That we use.
language, right? That we use to describe connectivity. We don't say 10.1.1.50 needs to talk
Needs to
to
have a
10.
route towards that
Exactly,
gateway and mhm.
exactly, exactly.
So how can I get started? How VPC Lattice helps me to fulfill that promise of giving my application access to endpoints without having to care too much about the low level details?
Yeah. I'm gonna give you a bit of a context
Mm-hmm.
into where Lattice helps you
Fits.
and helps
Mm-hmm.
developers get started with building connectivity at scale, endpoint connectivity, or application connectivity. Lattice is actually I would say, the forefront of what AWS calls application networking. Right? It's term of let's not do networking, right? I think I've just invented a term, networking. Let's do application networking. Let's connect those endpoints together, those databases, those applications, those web things that we create and we deploy on AWS. So Lattice started as an idea, essentially, of how can we make that easier. And we started from a very, very, very common problem, I would say, that or challenge that our customers have and had on AWS. You start with your account, right? You have the default VPC, you start in a region, and you start deploying your EC2 instances or your compute, whatever it is that you do, the infrastructure that supports your business application and logic. And you then go into this evolution stage on AWS and maturing on AWS and growth. And you are faced with having the need to have multiple accounts, right? Really good practice from a security perspective, and really interesting challenge that arises from a networking perspective, because multiple accounts means multiple VPCs. Every account comes with the default VPC, right? And you are now in a world where you have, let's say, 3, 5, 10 accounts and the same amount of VPCs, right? 3, 5, 10 VPCs in these accounts. And you're thinking, okay, well, I've deployed this application in account one, or maybe I've started with account one and I have some applications already here. And then I'm starting to deploy another application, another business logic function in this new account that I've created. And first, the question that comes up is, how do I connect these things together?
But
Right?
wait, can we just rely on managed services with public IP addresses like an API gateway, and that's my business service I want to connect to?
Absolutely. You can totally rely on fully managed services if everything is serverless or everything relies
Mm-hmm.
on API gateway, then you're
But
good. You don't even need to use
to
VPC
think
that
about
much.
that. Mm-hmm.
Yes, correct.
But the reality is more complex, I guess.
The reality is that there's a lot of things that require VPC infrastructure.
Mm-hmm.
If you, for example, start using or have a goal of using Amazon EKS, Elastic Kubernetes Service,
Open
or
search.
Yes, or ECS
Oh,
from
yes.
compute perspective as well, Elastic Container Service. Um, you then maybe your security team says, well, I want these Lambda functions to not just run as fully managed. I want their infrastructure to be in VPC for security reasons. And there are all of these added requirements, right, that usually stem from security perspective, where you want to have control over the network boundary of those services that you use, and you start deploying them in VPCs. And then you have to think about how do I connect these VPCs together,
Yeah, it's
right?
coming faster than we think. Even with the best intention to not use VPC, sometimes you are obliged because, as you mentioned, some services oblige customer to think about VPC. It's funny that you mentioned that because like 2 or 3 weeks ago, in this very same podcast on your seat there, I had another guest from a British company called Moonpeak, and they say we want to go fully managed and use only serverless and managed services, but sometimes we are obliged by AWS to have to create a VPC, and we do that only when we are obliged to do so. So if you want to connect the dot there, same, you go back in the history of your podcast episode and listen the episode with moonpeak.com.
Nice. I will go and listen to that too. I think there's a big trend around how do we have everything fully managed and we don't manage any infrastructure. I think that we're there in some cases. I think there's areas where, again, as I mentioned, either from security perspective, control perspective, you want to have that network boundary that is your VPC that you can fully control. So I would say, yeah, depending
And
on your use case, you will need to probably use VPCs at
And
some
it's a matter
point.
of reducing the surface of attacks as well. If I have a private API, there is absolutely no reason to put a public IP address on it. I want to keep it private, so private means inside a
Yeah,
VPC.
exactly. And you mentioned the keyword there, private. Many of my meetings with customers start with, we want private connectivity between these things. And private connectivity means usually not having public IP addresses associated with resources, means reducing that attack surface, means um, having different tools to secure that perimeter for protection, right? And this leads to the conversation of how do we connect these EPCs together? That's where we're getting at. And coming back to that default VPC, right, that you have in the accounts, that default VPC comes with overlapping IP space
And they all
in
have the
all of the
same
accounts.
IP range. It's 10 dot
Exactly.
something. Mm-hmm.
Exactly. And now you're going to remember, oh, I listened to Alex at some point. She was in this podcast and she was talking about VPC peering. Can I not just do VPC peering? Well, the answer is no, unfortunately, because you have overlapping IP space. And VPC peering, transit gateway, Cloud WAN, by default work with non-overlapping IP space. They allow connectivity at the network layer, right, for non-overlapping IP space.
Yeah, despite
Uh,
all the magic that we can put, or all the efforts that you can do, at some point we need to go back to the laws of physics or the laws of routing in this case. And we cannot
exactly.
route an IP packet in between two networks that have the same range of IP addresses.
Exactly. So here's where the journey starts with VPC
So
Lattice.
how can we do that? Yeah,
Perfect. Well, so Lattice, first and foremost, doesn't care about your IP addresses.
that's a good
That
news.
that's the best news. Yes, it doesn't care that your VPCs have overlapping IPs. It doesn't also care that your resources, your VPCs, are in different accounts. It is a service that you can use to connect endpoints, right? Clients and services and databases and resources across accounts, across VPCs in an AWS region.
Privately.
Privately, very
That's the
important.
important one.
Yes, everything is private connectivity. And it's not because it doesn't care about IP addresses or due to the fact
Mm-hmm.
that it doesn't care about IP addresses, and because it's an application networking service, It fully abstracts those IP addresses, right? So the fact that you have overlapping IP space doesn't matter. The other really interesting part about Lattice is that it defines a boundary by itself. And let's take a step back from that for a second. You are probably all familiar with two types of boundaries on AWS. The account, right, which is your billing boundary, your security boundary, permissions boundary, resources. You're deploying them in
Lives
an account.
inside an account.
Exactly. So your account is that first boundary that you are very accustomed to when you're starting to deploy or deploying, maturing on AWS. The second boundary is that network level boundary we've talked about, which is the Amazon VPC.
The VPC.
Exactly. So these two boundaries kind of are the things that customers had to work on AWS for a pretty long time, right? It's my security level boundary, billing boundary, and network level boundary. However, sometimes the business requirements are not necessarily aligned with either of these two boundaries, right? Because we get to things that need to talk to each other. And the fact that my application needs to talk to your application, for example, and we're in different accounts and in different VPCs, shouldn't impact the ability of my application to talk to your application, right? This is our business logic, and our business logic says these two things should talk to each other. But neither the VPC nor the account are boundaries that help us bring these two things together. On the contrary, they actually help us divide these things.
That's why they've been designed for at the beginning.
Exactly. So VPC Lattice introduces a new boundary. It's called service network. And the service network, as its name stands, it's a collection of things that you define based on your intent that need to talk to each other, right? That need to communicate with each other, regardless of their VPC, their account, with security policies on top.
So it's a logical layer above my account and my VPC that I defined, and I put things into there, and I'm vague when I'm saying things right now. We're going to go to the details, but basically endpoints. And as a developer, as an architect, I say, okay, this endpoint or this service needs to communicate with that endpoint, and I put that in the service layer. And then VPC Lattice does all the magic, and you're going to talk about that. I have questions for you, but I guess there is a bunch of NAT gateway and DNS stuff to make the two communicate securely, privately.
The good news is there is no NAT gateway.
It's even better for my bill.
Yes, exactly. The really, really good news is that Lattice is essentially an application level proxy, right? That takes your traffic from the client and says, client needs to talk to the service, this other client needs to talk to this other service. The service now becomes a client and needs to access this other service here. Perfect. That's great. That is the service, that is the function of the service network, right? And you mentioned bringing things into that service network or putting things into the service network. That's exactly how you can think of it. Lattice defines associations to the service network. So you can associate VPCs to the service network, you can associate services to the service network, you can associate resources, your databases, your compute, your web apps, your, business logic applications that you run in your VPCs, your Lambda functions, because we've talked about Lambda.
Including AWS services like S3 or DynamoDB, does it even make sense?
Not for that. Not for that.
No, because they have a public IP address.
And even deeper than that, if you want private connectivity, right? Because that's what everyone wants, no public IPs.
Private link.
Exactly, you have private link. And here's a really interesting area to sort of build that analogy in your head around what Lattice is. Because we as humans kind of tend to put things in boxes and we're like, okay, so this is not like a peering, it's like a new boundary, but it's like, how do I reason about it?
Service mesh? No.
Not a service mesh either. Not a service mesh either. The really good point, really good point. Let's come back to the service mesh idea for in a minute. But to kind of, again, add to that analogy and reasoning around what Lattice is. In your account, in your VPC, you said, okay, well, I want to privately access AWS managed services, right? And you started putting private link endpoints for S3. You have a gateway endpoint
Mm-hmm.
for DynamoDB, for CloudWatch, for like all the things that you need to access from your VPC, right? Um, Again, we're talking about things you need to access, right? Endpoints. That was the birth of application networking, private link, right? We are essentially, or private link gives you the ability to just drop an endpoint in your VPC that represents a service, right? Awesome. Customers loved it. Their private link is has been around for so many years and is really, really loved by customers. Now, we learned one thing very importantly from private link, which is how do we do this at scale? How do we do this for maybe thousands or hundreds of services that a customer might have, right? And they want to give access to these services in a client service type connectivity mechanism, but also whenever a client might become a service and then a service is also consumed, right? That bidirectional kind of connectivity where a service is not only a service, right? When you're talking through private link to AWS managed services, you're always the one initiating the connection, right? You're always the client in the VPC accessing S3 or accessing DynamoDB, right? Those services don't access your things
Mm-hmm.
back. They just reply to those connections. Well, commonly in customer architectures and service architectures on AWS, things are not usually only clients. They are clients at a time, they're services at a time, right? They can be accessed by some other things and they can access in turn some other endpoints. So there was that requirement of service to service communication, right? So again, starting from or building upon that new boundary, which is the service network, um, by being associated to the service network, you can be a client of the service network, right? So you can consume endpoints in the service network, or you can be a service in the service network, which means that you can be accessed by other clients in that service network.
Accepting connection coming from
Exactly.
other services.
Exactly.
From a developer point of view, what do I have to do to create a service network? I hope it's the
Yes.
correct name in
Yes.
VPC Lattice.
Well, you just go into the AWS console or use your favorite
Infrastructure
automation
as code, yeah.
infrastructure as code, and you
But
create a
the
service
basic
network.
building blocks,
That's it. It's just a service
that's it.
network.
Okay. And then
Yes.
I start to add my services in there.
Exactly.
Mm-hmm.
So, if we are to go through like a step-by-step thing that
Mm-hmm.
you would do, and I think Sebastian, you're gonna add some links to the
Yes, of course.
podcast to a really good set of blogs that we've published around how you can actually do all things with like console walkthroughs. I am a big believer in console, by the way. I learn all
To
things by
learn,
just
I guess it's
clicking through.
the best way
Yes,
to start learning a
exactly.
service. Infrastructure as
Um,
code is like a second phase after when you know what you need to build.
Exactly, exactly. So, as a step-by-step approach, you would first create your service network and you would share that service network with all of these accounts that contain VPCs in them that need to expose their services and need to access other services, right? The sharing mechanism is through Resource Access Manager, which you can
Mm-hmm.
use today to share a bunch of other things on AWS. It's not just specific to VPC Lattice, so same things apply. If you folks are familiar with Resource Access Manager, it works the same way. So you have the service network, and then all of these accounts where you have your applications, your compute, your EKS clusters, your ECS tasks, your Lambda
Database.
functions, your databases, your I don't know, your self-hosted databases, your RDS databases, your Aurora databases, all the things, right? As terms of infrastructure, are now looking at a service network. And they're like, okay, so what do I do with it, right? How do I start adding things into the this service network so that they can talk to each other.
And how can I consume this service? But I guess that's the second point in your. So
Exactly.
let's go step by step.
Exactly. So first, let's add things into the service network. And to add things, we need to know kind of what the things are. This is where the application owner persona is going to be getting very excited, because you folks are already familiar with this. You're familiar with load balancers, right? Application load balancer, network load balancer. Well, VPC Lattice gives you that load balancing functionality for services. So you were used to so far creating your compute and then putting a load balancer in front of it.
Yeah.
Yeah, perfect. Well, now you have your compute, and instead of putting a load balancer in front of it, you put a VPC Lattice service. That service gives you load balancing, gives you listeners and ports and protocol and routing rules.
So
and
the VPC Lattice service is the endpoint we were talking about. It's like the proxy you were talking about. Okay.
Exactly. So your VPC Lattice service is like your endpoint, the ingress into your application.
But
right?
It's a level 3 endpoint.
It's a layer 7.
I don't need to. Okay, so I have to deal with certificates and things like that.
Everything that you were supposed to do on your application load balancer, for example, you now do on the Lattice service.
On the Lattice service, okay.
Yep.
Next.
And you don't need your application load balancer. Keep that in mind. It's really important.
Yeah, it replaces the load balancer.
It replaces it because it provides you with the same kind of functionality. So now you have a bunch of endpoints, right, for your layer 7 things. HTTP, HTTPS, TLS. You're like, okay, perfect. These are my layer 7/layer 4 SNI routing things. But not all things are layer 7. There are some things like databases, right, that you don't really need to put a load balancer in front of them, right? So you don't need that load
load balancing stateful services.
Exactly. So how do we deal with that? Well, with VPC Lattice resources. You go ahead and you create resources. Same as you would create services, but just the fact that resources are not layer 7, right? They're layer 4. And you define a resource by specifying its AWS resource name, so ARN for RDS databases or Aurora databases. You would specify the DNS name of a resource if you don't have an ARN, or if it's not an AWS resource.
And one lattice resource per database replica or per database writer if I have multiple replica?
Actually, no, because the beautiful integration with Lattice for AWS managed database services, so RDS Aurora, means that those databases can be defined by ARN, and Lattice takes care of the magic under the hood to make sure that your active read-write,
spreading the load.
Yes, exactly, and the read-write endpoint is it's essentially making it look for you as you were in the same VPC as your database. Yeah. Cool. So we have services and we have resources. Perfect. Now, that's great. You're going to say, well, what do I do with them? Well, we associate them with the service network. We drop them into the service network, right? So far, so good. But there's no one to consume them. Exactly.
So I guess each of the service and each of the resource will get a DNS name that I can use in my application.
Exactly. So you get the DNS name of those endpoints, and now you need to be able to consume them. So to consume them, you, in the VPCs that you have clients, you take those VPCs and you associate them as well with the service network, right? Because we started at the beginning with the definition of a service network is a collection of things that need to talk to each other, right? So clients and services. What we did so far was to create that collection as a service network, to create the things that need to be accessed, services and resources, and drop them into the service network, and to then drop into the service network everyone who's a client of those services and resources. And that's it. These are the 3 big steps. Yep.
And as you mentioned, if you scroll down in your podcast application, you will find blogs written by Alex and other blogs, and the links to the documentation to help you to get started. I wish I talked to you earlier, like 2 years earlier, because I feel I understand Lattice now, which I didn't fully understand before. So you explain things in a very progressive and very easy way to understand. Um, from an application point of view, I take my developer hat back again. So at the end of that configuration, I receive DNS names for my different endpoints. I can use this DNS name to talk to the service. The service will load balance the request across whatever is consuming my service behind, or I can access resource as well. And a service can be a client as well, as you mentioned. It's in both directions. And it works across multiple accounts, multiple VPC, overlapping ranges of IP address. What's the magic? We are not going to dive into all the details. We don't have time. I keep an eye on the clock there. But can you give us a peek of how it's working behind the scene?
Well, that's the AWS secret sauce, right? Um, well, so I did mention a bit at the beginning that Lattice is an application layer proxy, right? So because it is a proxy, we have a very highly scalable, resilient architecture under the hood that allows us to, or allowed us to innovate in this space. I think the reason why you mentioned that it took quite a few years for people to kind of fully grok it, of like what is it exactly and what it helps with. It is because it is very innovative in the space. It's taking networking and it's putting a layer of abstraction on it, right? You don't care about routing. You don't care about
Mm-hmm.
routes, route tables, and all of that. You just care about that DNS name. And this is a thing that network engineers, I would say,
Are not
myself
used to.
being one
Mm-hmm.
for almost 17 years now, have tried to do for a very long time, even in the data center. In the data center, there was probably the gap between the networking folks and the application owners was even bigger because there was a lot of physical stuff that was happening that the network people needed to look into and take care of. And that gap being so big, it's essentially driven networking folks to try to abstract it as much as possible, to try to have application owners and developers not have to worry about it. And we've tried doing that with routing protocols. We've tried doing that with SDNs, and we've tried to do that with like a lot of technologies that came right in the evolution of networking that were sort of intended to do this, right? To capture intent for connectivity and to say, okay, based on your intent, this thing can talk to this thing, right? Lattice, I think, is this piece of innovation on AWS that actually allows you to do that successfully. And it allows you to capture intent from developers and app owners that say, hey, I'm in this VPC in this account and I need to talk to these 5 applications or these the 3 databases. Perfect. Let me connect you to the service network. You have all the endpoints that you need here. Here are your DNS names. Go for it, right? Without having to actually worry or have any sort of skin in the game for the networking actual under the hood piece.
But I didn't realize that to make that happen, we need to provide some compute. You mentioned the service. I imagine there is some EC2 behind the scene that we need to keep highly available and scalable as well. And something I learned through my 10 plus years tenure at AWS is that if there is pressure on our infrastructure, there is a cost for the customer. So how much does it cost? Of course, we are not going to go into all the details of all the metrics because I guess it might be quite complex. But what are the key metrics or developers have to think about when using Lattice?
Well, I'm very happy that you asked actually, because with the pricing model for Lattice, we've tried to solve another pretty interesting challenge that that customers had in traditional networks, where the network is the pipe is shared between
Mhm.
everyone. Like everyone just uses the network. And it's really hard for the network folks to do cost show back or to say, hey, this team is using 2.5% of the
Mhm.
capacity and this other team is using 10% of this transit gateway, which in all honesty, it is hard because the network is a shared pipe and
You
you don't
cannot
have
tag bandwidth.
visibility. Exactly. Um, so Lattice solves for that. The pricing model for Lattice is for services. It is associated with the service. So if you have a service, you spin it up. It contains that load balancing piece, that compute under the hood that does the load balancing and all the logic, control plane, high availability piece. And that is what you are essentially paying for. It's data processing costs and hourly costs for the existence of your
Yeah,
service.
so per
Very similar.
hour and per gigabyte going through or something like that.
Exactly,
Hmm.
exactly. Per hour cost per gigabyte of data processed by your service and per number of requests. We have a really big free tier request for that. I think it's 300,000 requests per hour. That's the free tier, and then you are charged 10 cents per million requests. I hope I got that right and I remember it, but you folks find it in the documentation if I didn't. Um, it's really important to think of it as your load balancer cost,
Yeah,
right? It's essentially
it
replacing your load
offsets
balancer.
the load
Exactly.
balancer. That's for the service, and then I guess for the resource as well.
Yes, resources again have an hourly cost and have a data processing cost associated to them. Really easy, really straightforward. No request charge for resources. So keep that in mind because they're just TCP in nature. There's no cost for the service network. There's no cost for being associated as a client, like a VPC, to the service network. There's no cost for associating services to the service network. There's a cost for associating resources. That's the hourly cost, essentially, for resources. So the cost model for Lattice is thought of to accommodate and promote essentially
Hmm.
scalable connectivity on AWS and your ability to connect thousands of services and resources across accounts to clients that need to consume them.
In last week episode, we were saying that before the cloud and now in the cloud for large organization as well, we still see the division between a networking team laying out the infrastructure and the development team deploying on top of that. How do you see customer using VPC Lattice? And you still have the networking team preparing the service layer and the different services and then the developer using them? Or it's more, are we shifting the control more to developers?
That's a really, really good question. Um, and I think we do need to bring into the picture that third persona that we kind of left behind a bit in our conversation, which is the security persona
Hmm.
that wants to have full visibility and control over, hey, app one talks to app two, but should not talk to app three, and this client should not be able to access the database, and so on. Lattice does provide the ability to associate auth policies to your services and service networks so that you can very granularly control in that common boundary, right? To add fine grained controls
Who's
to
talking to
say
who? Hmm.
exactly, exactly. So these three personas kind of come to the table
So the
in
network, the application, and the security.
exactly. Thank you
Hmm.
for that. These three personas come to the table in pretty mature organizations, right? Where processes are established and there's usually different teams that the network team probably today deals with the transit gateways and the cloud WAN. Application owners own their load balancers and there's maybe a platform persona as well involved there that manages the Kubernetes platform or the compute platform, and they come to the table and they kind of start dividing their roles into VPC Lattice, right? The network team manages the service networks, the app owners or a persona, the platform persona manages services and resources and defining them and creating, like, associating them with the service network, and then the security persona comes in to say, I want these nice auth policies in here, and I want to have access to all the logs. Lattice publishes access logs, and you can see in there exactly who talks to what in your service network. So yeah, kind of this is how mature organizations are adopting Lattice. However, there is a very interesting push from new organizations, from today's developers, the folks
Like the
who
cloud
are
native, like we call
exactly,
them.
exactly the startups world, the folks who need to be like really fast and agile and just need things to work, where these roles become much more decentralized, right? There's not a team of three people who are doing networking usually. There's just a team of developers, and this team of developers says, I
Now we
want
need to
app A
deploy
to talk
something.
to, yeah, exactly. I want these apps to talk to each other. And at that point, it doesn't really matter how many of these services or resources you have, or how you connect them. If you have one service network or five service networks, doesn't matter. They start by doing things based on their intent. If tomorrow, say, I need to connect to this database, they add the database into the service network. If the day after tomorrow they say, oh, we need this new business use case for some SaaS provider, they just create another service network. They expose their whatever endpoints they need to expose. They connect that SaaS provider into the service network. It's a very dynamic and agile kind of deployment where what matters is, can A talk to B? And if it can't, let's get them into the same service network so that they can. Very, a bit, very different, I would say, than traditional networking where you have the router that connects you, and you have this kind of hub and spoke architecture where you have a central point where you need to go through to actually be able to do service to service communication.
And at the end, you can describe your VPC Lattice infrastructure in infrastructure as code. So I can have a CloudFormation template or Terraform or whatever you
Absolutely.
prefer, and make it part of your application source code and deployment strategy.
Yes, 100%. And we have actually just seen a couple of days ago, customers a customer who's done a really neat infrastructure as code, and together with Q, Amazon Q,
Mm-hmm.
to essentially add tags to all types of resources, tags to the service networks, tags to VPCs, tags to services, then tags to resources. And they've created a really nice graph where they have essentially everything that connects to everything. They've taken access logs. They know exactly what connectivity patterns they have, like who talks to what, right? And every time they need to go update that, they just do essentially in that graph, they do a drag and drop, which translates into a PR in GitHub, and that
Wow.
PR gets approved. And it's essentially that intent-driven connectivity, right? It's literally very close to the end user, the end application owner, who's like, like that's what I need to do. There's also a really cool part of in the approval process. They have pre-approved patterns, and they have exceptions that are raised where that security owner persona comes into play
To review.
and says,
Mm-hmm.
you're kind of trying to do something weird here, and we're not allowing you as per the organization policies, which is really good because you have now the ability to do that. You have the tool to go and restrict service one from talking to service two.
I'd love to dive deeper into that, but maybe we should record a third episode together.
I would love that.
I know you cannot talk about the roadmap, but what are the trends you're seeing from a customer point of view, or from an industry point of view, in this domain of how you call it, application networking?
I would say probably one of the most important ones is global connectivity. Here is where
With multiple regions, you mean?
yes, yes,
Mm-hmm.
yes. Having services, resources deployed across many AWS regions. I know we always say, don't create cross-region dependencies. Try to keep those at a minimum. The reality on the field, on the ground, is that there are a lot of services that talk to each other across regions for various reasons. Now, Cloud One makes it makes it really easy for you to do that. But then again, it's a layer 3 connectivity option. Lattice doesn't yet support cross-region connectivity, but it is something that we are actively exploring and trying to
Thinking about.
understand. Yeah, how would we make sure customers do the right thing still, right? And they don't create these dependencies without thinking about them and rationalizing about them and knowing about them. And how do we make it easy for them to connect at the same time?
The reality with very large customers that they have multiple cloud providers, at least 2, sometimes 3, depending on their history. Can we dream about a world where one day it will be possible to have like this kind of service layer connectivity in between multiple cloud provider or on-prem and cloud?
We can dream, yeah, absolutely.
Yes, dreaming is always.
Absolutely. I would say this
What's
landscape is
missing today?
continuous.
Mm-hmm.
This landscape is continuously changing, and I would say that in this space, at least for cross-cloud and even cloud to on-premises connectivity, there is still that big dependency on network reachability, like layer 3 connectivity. I still have to have IPs and I still have to route IPs. Yes, exactly. Lattice can work, and we have a bunch of customers who've brought in their resources and services from on-prem or from other clouds into the Lattice world in a region using resources and layer 3 connectivity.
Yeah, they
so
can
you can
develop that
exactly
on top of the construct
on
that
top
we give
of
them.
the layer 3 connectivity. Exactly. I would say that the future is probably somewhere where that need for the layer 3 connectivity is also abstracted. It will take a bit longer because it is the world where we kind of bump into the physical aspect of it, right? Direct connect takes you to your on-prem and you have like actually some connections there. But I do think that space is evolving. So I would stay tuned. I would stay tuned for all the cool things that are happening in this space.
And come back to the podcast in 1 year or so that we can see how it evolved.
I would love to. I would love to come back earlier, actually, not just 1 year.
As soon as there is something to share with developers, let me know. And the door is always open. You're always welcome. Thank you, Alex. Alex Widish, your principal networking specialist, solution architect in the networking group in the Amazon VPC team. Thank you for having listened to this episode until the end. I hope we we start your curiosity, at least if you want to learn more. And all the links and even more are in the notes of this podcast. So be curious and learn more about Amazon VPC Lattice.
Absolutely. And I just wanted to add one more thing. If you folks have questions, if you want to reach out, please do find me on LinkedIn. I'm there, or whatever other social media platform you find appropriate. Let's chat more. If you have questions, if you want to know more about VPC Lattice or other AWS networking services, reach out.
And the link to your LinkedIn profile is also included in the notes of this podcast. But now, go build.